College Algebra 2.6 to 2.8 test review. For examples 1 through 3, we are evaluating piecewise functions and graphing them. So let's start with looking at the evaluation part. You can use the graph if you want to, but let's just use the equations for this because our graph may or may not have these points perfectly on them. So whenever we're using the equations, we're just taking what x equals, so whatever's in the parentheses here, and we're deciding should we use our green function or should we use our pink function, depending on where 0 lies in our domain. Is it less than 3 or is it greater than or equal to 3? So whichever one it falls into, that's the function we're going to evaluate it at. For graphing, remember we're kind of splitting the graph into two. The left side of this vertical line at 3 and then the right side of this vertical line at 3. I'm using 3 because that's what is defined up here in my domain. So to get my green graph, I'm going to plug 3 in, see what happens. Then I would plug in 2, and then 1, and then 0, however far I need to go to get some points and see what my graph looks like. To graph my pink function, I'm going to plug in 3, see what happens there, and then plug in 4, 5, 6, see what my graph looks like. Remember, at 3, my green function will have an open circle because there is not an or equal to sign. And at 3, my pink function will have a closed circle because there's an or equal to sign. For problems 4 through 9, you should review the parent functions that we went over in your notes, so you know what each shape of these looks like. And you can do it one of two ways. You can use transformations. So for 6, I think transformations are really easy to use to graph that. I don't need to use a table. Same thing with 5. Same thing with 8. Same thing with, well, most of them. But that it might be easier for you to use a table on some of these. So for 4 and 8, I've kind of set up your tables. For 4, since you have a 2/5 out front, you're going to get decimals. If you don't, or you're going to get fractions, I guess. If you don't like fractions, change them to decimals. If you don't want to graph that either, then go far enough in both directions so that you get whole numbers. So you'll see here, I got a whole number answer here, a whole number answer here. If I would keep going, and let's see, what's my next whole number answer? I believe plugging in 9 would give me a whole number answer as well. So if you just keep going on your table, you'll get 3 nice points. You just may have to do a little bit more work. For 8, I plugged in specific values for x that would make my radical on the inside a perfect square. So when I plug in 1, I know the inside's going to be 0. That's a perfect square. When I plug in 2, I know the inside's going to be 1. That's a perfect square. When I plug in 5, I know the inside of my radical is going to be 4. Again, perfect square. So I didn't have to deal with any decimals here because I was smart about what I plugged in. So for all of these problems, you can use tables just like this, but you need to know what the shape of the graph looks like so that you know when you have enough points. For problems 10 and 11, you need to know which function those correlate to, so make sure you know the equation or what the equation looks like given the graph, what their parent function is. And we're just going to use transformations here. So on 10, I know that it went right 4, up 7, stretched by 2, and it reflected. So I would take my, in this case, quadratic parent function and plug in all those transformations, and I would have my equation. Same thing with 11. So look at how it's been transformed and use the correct parent function. For 12, we have a piecewise function. So I've set up my f of x equals curly brace, and I'm going to have 3 different equations, my red equation, my green equation, and my blue equation, and then 3 different domains. I got all of that from looking at where on the graph those 3 graphs were. So I'm looking at my x values. For 13 through 16, actually let's 13 and 14, you could start by evaluating f and g at the number given. So for 13, I would first find f of 2 and g of 2. And then I would add those 2 answers together. For 14, I would find f of 1, find g of 1, and then I would multiply those 2 answers together. For 15, you can do the same idea, find f of 3a, g of 3a, add answers, and same with 16. For 17 through 19, we're not evaluating at any particular number because I have an X right here for all of the problems. So for 17, I'm just going to add the two functions together, combine like terms. Or for part B on 17, I'm going to multiply them, box method or FOIL. For 18, I'm subtracting them. Make sure you put function f first, and then make sure you distribute your negative to function g. And B, dividing, just put one of them over the other. For 19, I'm adding them and dividing them, just combining like terms and dividing. For problems 29 through 31, we're taking the number that we're evaluating at. So for 29, we're going to take 5, and we're going to see what g of 5 is. So I'm plugging 5 into g. Look up at the table that uses function g, find where x is 5, see what your y value is. In this case, it's 9. So now we're going to take 9 and plug it into function f. Go up to function f table, find where x is 9, see what our y value is. So my final answer for 29 is 0. For 30, we're just going to use function g twice. For 32, 33, 34, 35, we are finding f composed with g and g composed with f. That's not multiplication. Make sure you notice that it's an open circle, so don't be multiplying these. I've set up number 33 for you. We're going to take function g and we're going to plug it in to function f. Make sure that we are using box method or FOIL right here. Anytime we have a binomial squared, that's what we need to do. I know that you're all going to be incredible and you are going to rock this test. Good luck.